So, good evening, everyone. Welcome to the latest and one of the safest, if not the safest, presentation this evening. So, just make sure I'm putting the device here. Let's close it a bit so that we get a nice better way. And if I was long enough, I can probably put it on the wall also. But I'll just put it here. The talk will be about this device. It's a device with open source software, hardware, done from a software engineer that has no idea about hardware. And it will be more information about my journey, the tools that I used, mistakes that I made, and hopefully you can learn from this. So please don't smoke in that direction. Yeah, most of the times, for your convenience, I put also QR codes so you can just scan it, or on the FOSDEM website, you can see also the slides. And you can see the same content as here. Okay, so what I'll be talking about is I'll be talking about our dream, what we wanted to achieve, how we actually started with this idea. Usually a dream has some motivation. Then I'll be talking about the team. I'll be talking about the creation of the device itself. And then I'll open the door for more people to join and more things to improve. One of the things when you start working with open source projects, be it software or hardware, it's a never-ending task. You can always improve some small thing here and there. You can always do something better. And there is always somebody that will tell you this and hopefully will help you to do this. Okay, so it's a long story, but I'll try to make it a bit short. And my family has a vacation home, which is not quite often used. And we thought, would it be possible? We have still neighbors, but they're a bit far away, to have a device that can inform us via Wi-Fi if there is a smoke. If this thing starts to burn, we have to inform somebody. The neighbors are away, but we can, if we receive some information, we can just call them and hopefully save further troubles. Also, the fire brigade will come and all will be good. And we started talking with my niece and with the other parts of the family. But what about when the cleaning lady comes? Wouldn't it be nice if we have some information if somebody entered? And then what about when we are not here? Would it be nice to, if somebody entered the house without permission, just to have an alarm so that the neighbors can hear this and probably check what's happening in there, and things like that. And we started discussing a lot of situations. For example, now we're here with the kids, and we don't want all this beeping and sending information via Wi-Fi to somewhere. Can we have just this mode that we hear in some of the small shops, the ones that are almost gone, where you enter and you see beep, 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 and the kids are here or somebody just entered, and you can walk and so on. We have this device is having motion detection. It's having also a smoke detection. It's having some other parts that I'll be talking about. And we wanted to create such a device. And so we know that at that time, such devices existed, but for a price range that was not quite good. For example, as the price of this one at the moment. And as a software engineer and a person who is a big fan of open source, I started to think, can we make something like this? Can I make with a team something like this? So first I want to improve the security of my house, but I want to, I at that time knew that I will not be really able to do all parts. So I wanted to use the open source development way and to give the freedom for somebody else to improve it, to add another functionality. Maybe you already have an idea what functionality this can be. And in addition, to allow us to legally, to an extent, to modify this and use it for our needs. And last but not least, so I knew that it's possible to create a device, just a bunch of wires, plug it, but we wanted something some like finished product. We wanted to have a box. We wanted to have all things covered, easy to assemble, disassemble, just put it there and use it. And so I was quite open for all the ideas, and I thought, why not? Why not give it a try? Maybe we will succeed and do something. So I'll present to the team. That's the initial team. There are also other contributors, small and big one. Let me present myself. I'm the software engineer over there. I'm the person who knows how software works, computer languages. I'm quite skilled in some, and it's relatively not easy, but straightforward to switch to another language. I know that I need some short time span to switch to another language, let's say 2 months, maybe 6 months to become good, a year or 2 to become really good, and a lot of years to be expert. After that, we have a hardware guy. So I don't do hardware. I solder the wrong pins. So the hardware guy is a really skilled and patient guy. And for him, really, assembly is a high-level language. So he is looking at the bytes. He can measure the batteries by their weight. So we are talking about some other reality for me. I didn't know that such people exist. Then we have a designer who is actually a really, really famous, good designer. He has, if you know this, Red Dot Awards. He has 4 of them. I'm told that this is like the Oscars of the design industry, and he has 4 of them. Accidentally, he goes also to the mountains, and we met there. And also, there is a 4th guy who is the mechanical guy who makes all the nice graphs and so on. And some of you may ask yourself, why 4 guys? Can you just make this thing yourself? I thought the same. Why really? Maybe I'll not do something like a good design, but something acceptable. So no design is needed. Mechanical designer, I used to change the first example from Blender. That should be enough also to make mechanical design. And then for the hardware, I had a brilliant plan. 1 week expert in hardware. I asked my good friends, and they told me, you have to buy The Art of Electronics, if I'm not mistaken, from Horowitz. Read it, get these components, and see how it goes. If you burn all of them, then it's not good. And I started really for a week to solder and so on. I got distracted, burned my first component. Then I think even before the end of the week, I knew that if I want to be expert in this, if I want to be good in this, it will take at least 2.5 years full time. And I had only 2 hours a day free time, even less. So at some point, I knew, I hope quite soon, that things will not go with one person. If one of you here is a genius, and I saw some geniuses, then definitely you can do it yourself. But when we create something, we need to be experts in different areas. So if I started as a kid, probably also to do 3D design and hardware, maybe I could do it. Unfortunately, I started with software. And also, there is a communication, there is understanding about some properties, there are requirements that I have never ever knew. For example, that the plastics, depending on the plastics, it can, and depending on the technology, you have to put additional spacing. Otherwise, the machine cannot exactly up to the millimeter do whatever you want. And things like this. And if I was doing this, probably after 25 years or when I retire, I'll have enough time to finish it. But for me, that was not quite good. But let's go to the requirements. Now, I thought, okay, we have a team. I have very good requirements. So it needs to have this motion and smoke detector. That's fine. In the beginning, because I met some people and they said, hey, I made a motion detection, and another person who said, I made a very low efficient smoke detection. Okay, let's try to use it. One of them said, I am perfectly fine to be open source. The other one was not quite interested. So we wanted to have a nice and polished look. We didn't want to look like something that is already in the market. okay, here is the star designer, he can help us with this, to work on batteries. So this thing, because we're not that often, and the neighbors, they are not also that often, should last for a year. Hopefully for a year, we'll go there, we'll be able to change the batteries if something goes wrong, and so on, to be remotely upgradable. Why? Well, there is security problems every day. The Wi-Fi stack problem, so you update the version. Some other problem, you want new functionality, not just problem. So you constantly want to be upgradable and to be open source. And now, when I say open source here, I wanted to, so I was the one responsible for the software, so it will be open source software. But we wanted to be also open source hardware, so you can really produce this device, just having the specifications, the PCBs, the all schematics, and everything up to the last component, plus the link from the website where you can buy the component. And I just wanted somebody else to help and to improve it, and hopefully to come with good ideas. As normal open source software works. So I had initially also an idea to create all of this using open source tools, but I met a resistance from all the people because they were skilled in this tool and they didn't want to try another one, or it will hinder their creativity. So most of the people are quite creative. So I made a compromise, said, okay, let's make it like this. Do whatever you want, use whatever you want to, but at the end, the final result should be viewable, modifiable from open source tools. And I'll try to take care to find the tools. So now we're coming to this device. This is the UKit device. And as you can see, it has this look. You can put some batteries here. It works with the same batteries like the famous cigars, e-cigarettes, and so on. And it has different modes. We decided to go only for 4 of them, so we can detect smoke. That's the initial mode, and then you trigger an alarm. There are also modes where you can detect smoke and detection, be informed over the internet, don't be informed over the internet, or just turn the silence the buzzer so it doesn't sound an alarm. And there was also another requirement. The people, if somebody enters in your house, it's probably quite skilled guy. So this device had to wake up for 1 second, second and a half maximum, to wake up, to send an MQTT message to somewhere over SSL, that's what I thought in the beginning, and finish. I talked with the developer, with the hardware guy, and he told me, well, good thinking, but the way you want it is not possible. First, so I said, let's use ESP. I know this. It's quite nice, easy to program, very fun thing. And the device, most of the places you see, it's low consumption and so on. For 1 year, it will not last probably a week. So the hardware guy informed me that we need a second microcontroller, and this is a Tiny 1634. Really ultra low power consumption. You can see some of the hardware specifications here. So we ended up with actually 3 controllers, microcontrollers, ESP8266 for the Wi-Fi, a Tiny 1634 where the main logic is going on, and we ended up with a Allegro microcontroller, which is for the processing of the smoke, but this one doesn't need to be programmed. The device looks like this. Now, in the source code is, and the repository is divided into different subparts. And if you go to this URL, you'll see all the needed things in order to print this. In order to print the PCB, all the needed components to solder them. Of course, you have to buy them, and to create the device. But what we achieved is a form factor that is easy to assemble, not exactly small as a device. I was thinking about a really small device, but then you end up in a situation where you cannot buy this commodity components for cheap. So that's what we have here. And we used a couple of tools. Now, the hardware designer was again, very patient guy and actually quite interested in learning new things. So we started using UKit. Most of you know it, quite a good tool. Multiple problems that we had. For example, I'm working on Linux and he was working on Windows, and constantly we had to do something with the paths. After that, some things were missing and so on. Those of you that work with UKit and worked only on one platform, let's say Windows, they were probably quite fine, but we discovered some things that we didn't know and were difficult to explain. After that, we used other tools. For example, when I say, can you move this whole 5 centimeters in that direction, and he says, I did it, here is the file. I'd like to see visual difference. I'm a software engineer. I'm used to different tools that compare text. And in text, you can quite easily see this. But here, when we're talking about PCBs, it's a bit different. So what we used is this tool, the second one from the top, and this one can give you quite nice differences. You can see with red where the new change things. And you can integrate all the things. We have also other tools listed, for example, for the difference in the schematics and so on, so that a person like me, a software engineer, can understand what's happening. And if you go to this address, the last address, you'll be able to see all the tools that we used. And this helped me really a lot, because when I say to the designer, or hardware guy, can you do this? He makes it. After that, he comes to me. He says, I did it. That's it. Happy? Yeah, quite happy. So after that, for the enclosure, so the mechanical designer and the designer, they use their own tools, but we ended up with step files or some easy to open from FreeCAD files, and we used FreeCAD daily, the latest and greatest versions, in order to be able really to work and to understand what's happening. Now, when I received the first design, I was so excited that I started, doing prototyping with this stereoform. And then I presented it to the designer. He looked quite suspicious at me. He said, are you going to produce this with an axe and a hammer? I said, why? Because this needs to be millimeter exact. This needs to be absolutely exact. You cannot just have 2 or 3 millimeters. You don't have too much room to do this. And then, after a bit of research, we found the UKit step-up tool, which is an add-on which, for FreeCAD, it allows us to get the PCB as it is directly, put it in FreeCAD, and see how it looks like. So we didn't put all the components because at that time UKit didn't have all the components. We just put the most bulky ones, or we created some of the bulky ones, that we have an idea about the measurements. Here things are quite close to each other. And then we used also another tool, which is this exploded assembly. The exploded assembly is nothing really that helps you to develop faster, but it gives some nice pictures and impressions for the people that want to see what the device is doing and how to open it. So I have here a video. I don't know if this will work, probably not. But yeah, there is a link. So when you open the video, you'll see that this starts to open up in all directions, looks pretty nice, and you get a good idea. And this is something that the commercial tools also can do. And suddenly, open source tool is allowing you to really see this and understand how the things are working. So I was quite happy with the tools that are available for creating the plastic enclosure. Okay, now about the software. The hardware and the enclosure, there were problems with the tools and so on, but it was relatively straightforward. And hardware doesn't move so fast like software. In software, especially open source software, it has one big advantage and one big disadvantage. The open source software is moving quite fast and it changes quite often and breaks things. That's the advantage. And do you know what's the disadvantage? The same thing. The same thing. It can turn against you when you use it. So I started working on the software. And on the bottom, you can see that there are two things that were crossed out. So We wanted to put on not only the firmware, but to create a mobile app based on some tool that can create multiple versions for iOS, Android phones, and so on, make the web API and so on. I started with Angular 1. At some point, they moved to Angular 2, and then Ionic decided to use TypeScript, and oh, hell on earth. This is unsupportable. At the Node.js, they sort of don't move that fast, but still, let's say I used version 4 to create the web API, and then suddenly version 8, and then 9 and 10, and simple, small things. I want just, to make a call to receive it. Why you have to constantly change the API and so on? So that was a big pain point for us, and we gave up with this. If somebody is interested in working with this and quite skilled, then he can help us. But we concentrated on the software for the two microcontrollers. Since I started from the bottom, I'll continue from the bottom. The Artini software, and this microcontroller, you don't have much space. There is a tiny space in there. To achieve this 1 second response, sending it over the internet, using SSL, connecting to the point, and so on, you have to optimize on every level. And the hardware guy said, well, you use assembler. We can fit in this space, and so on. And he not only fit in this space, but he was leaving even some additional space. And I thought, I can put a bootloader there. Because I want not only to update the ESP, I want to update the Artini. So we ended up with a slightly modified version of TinySafe bootloader, and it worked quite nicely. For the ESP part, we used Swing framework, and I suddenly ended up as the release manager and contributor of Swing framework. So what I needed is, I was needing something I thought quite simple. I need MQTT, protocol simple. If nobody created it, I'll create a client for this. Plus SSL connection to this thing, plus a bit of fingerprinting so that suddenly I don't send to somebody else. And it took quite some years to reach this 1.5 seconds execution. I started using, for example, on Arduino, and I thought that will work. They have everything. After 5, 6, 10 seconds, you may succeed. Not exactly what I want. I want this to succeed always. Plus, the second component, and to have the big component, and probably I'll go to a more detailed chart. Oh, no, it's not here. We had JavaScript. JavaScript is there. It's a JavaScript language. And what I had there is if somebody, we have all these events, smoke, movement, and so on. If somebody wants, why not give him the chance to program additional rules directly on this device? Why it has to go to a service somewhere in the world, in the States or somewhere in Europe, then do something and come back to me? I find this not exactly optimal. So JavaScript was the tool that we used to help us to implement this logic, additional logic. Now, I'm coming also to the closing, so I hope I have 1 or 2 minutes for questions. I wanted to answer this question. Is it possible to create open source hardware and smoke detector and make it really also modifiable with open source tools and so on? For me, the answer was yes. Yes. Was it easy? No. Now, if you start working with open source tools, you have to understand this. They change. And you learn something, it breaks, you end up modifying so many things that at some point you have to stop and say, hey, I cannot now fix AngularJS. This is too much. And but it was fun. It was great fun. I learned a lot, and I think we spent most of the difficult years of developing, or the difficult times of developing a hardware project, and they're behind us. So now we can only upgrade it and make it better. Are we done yet? That's what my kids usually ask me when I start putting them in the car, and after 5 minutes, are we there? Are we done yet? 80%. I can flash it and then configure it and manually, and it will work perfectly fine for even 2 years. But we need the 20% to attract more normal people, so no flashing and so on. So we have actually a lot of work. So if somebody is now having a lot of free time, wants to join us, please join us. We have documentation that needs to be finished. I'm not giving this to you. I know that most of the software and hardware people don't want to, but we need to improve here and there something. We hope that we can decrease the size, the form size, and so on. And yeah, such projects, they develop constantly and they need your help. So if you want to help, there is a URL. And usually I'm asked this: are you ready for mass production? Maybe with an axe and a chisel, we can do it. I actually went to Portugal, especially to ask the European mecca of plastic enclosure producers. They had a price, very good one, double the Chinese, but still a good one. Plus, they said the weather is good, you can enjoy the weather. Now, I hope I have some time for questions. 2 minutes for questions.
Is it possible to 3D print the enclosure on an FDM printer, or does it have to be...
Okay.
Repeat the question.
So the question was, is it possible to print this on a 3D printer with FDM technology? Yes, it is possible, because we started actually printing it on such printers, and we were always getting some problems from the printing houses, and they said finally, okay, make this a bit bigger, make this a bit smaller, you can print it. And we have also. Yeah.
Can I ask what the price of the components are?
So now, if you're standing, please sit. At the moment, this thing costs around 250. This is unique. Euros. We in Europe. So Turkish liras before. Now, of course, the plastic enclosure is the one that is costing 210 maybe. All the rest is the components and the manual configuring and so on. Actually, if we start mass producing, we can go to a price below 40, even 40 euros, which is sort of competitive price. For me, 25 will be the best, but yeah. Other questions?
Yeah, I just had one over here. Can I actually use that in my house as a smoke detector? Is that certified?
Very good question. No, that's not certified. It's not certified. It's a companion that you can use. For certification, we need to invest. So first, when you certify something, you have to be sure that the enclosure is final, and the software is more or less final.
Right. Well, the new standards for smoke detectors, because I'm perfectly involved in that industry, is 10 years on a single battery.
10 years?
10 years. And
wow.
you need to discriminate. You need to be able to discriminate nuisance alarms versus real smoke. If a hamburger is starting to burn, your alarm cannot go off.
So yes, this is.
So as a hardware guy, that last 20% takes 80% of the time.
And as a software guy, I can tell you that it's the same. It's absolutely the same as a software guy. Okay, another question?
Do we have?
Yeah, over
there. Had you taken a look at other projects in a similar space? I think of one from Stuttgart dealing with fine dust detection. The project is called Luftdaten or Airrohr in German. And so maybe you could learn how they did things and how they approached the things.
So we started quite a long time ago, maybe 4 or 5 years ago. You know, I have only 2.5 hours, and 2 hours I need to feed the kids, and then 15 minutes for my. I'm living actually close to Stuttgart. At the time when we started, of course, we researched that there is another project. We couldn't find such a project that we wanted, so we decided to do it ourselves. Typical for software, for open source, you know, typical. But I would love to connect with the people, and probably we can exchange some ideas. And probably they'll give me hints. I only can give hints for software.
Okay, so I think we're run out of time. So thank you for our last speaker.
Thank you. One of the safest presentations. You were safe here.
So unfortunately, the time has come, and that was the last presentation in the embedded dev room in this year.
Hi, can I